Hello, everyone. Welcome to today, a couple minutes with math. Hopefully, you've got something, maybe music playing or in a comfortable place. I know that learning math by video and without being able to interact is a little hard, but hopefully, I can say this in a way that kind of makes sense. You can always rewatch this and look elsewhere if you need. And the helps that are given in the homeworks on the school site that'll help you do well on this. So, we're going to talk a little bit today about factoring. Let's see if you remember what that looks like. Factoring or finding the factors. It's kind of like what factors brought you to be watching this video. If you think of what are the factors that caused you to be watching this video, you can think of the reasons you're watching this video. And those reasons aren't mentioned, or they're not out there. They're not really known. They're not part of what we're doing, but they're there. You're watching this video, and you know what factors are involved in it. Factors with numbers, it's the exact same thing. For example, the number 24. What numbers factor into that number, or what numbers make up that number? And in factoring, we're always talking about multiplication and division. So how do we get 24? What creates 24? Well, 6 times 4 does, so those are factors of 24. And you've done this before. You've even seen greatest common factor. 12 will factor into 24 by multiplying by 2. 8 will factor into that by multiplying by 3. And yes, 1 goes into 24, and it goes in 24 times. So those are factors of 24. Well, what about what we're going to be doing today? What we're doing today, factoring today, is with expressions. In factoring expressions, it's the same idea. It's exactly the same here. We're trying to figure out what multiplies up to get into that. We're doing the opposite of the distributive property. We're pulling out the numbers. We're dividing out the numbers that are in both of them. And yes, we are looking for the greatest common factor. What's the biggest number that goes into both of those? And we do need to kind of rely a little bit on our times tables, on what we've memorized in multiplication, because 2 does go into both of those. So if I pull a 2 out, if I divide a 2 out, let's see, if I divide a 2 out of the 16, then I'm left with an 8 on that. I'm left with 8 y's. And you can check to make sure 2 times 8 is 16. Yep. So what do I divide off this positive 24? If I take the 2, divide that out as well, I'm left with 12. See, there I go. I have now created an item by factoring out of this expression. But there was more I could have taken out. So I've got to find a bigger number than 2 that goes into both of them. It's like popping a zip. You want to get all of that stuff, all that pus out of the zip. You got to find the most amount, like get it so it's all the way out. Well, 2 would work, 4 would work, and I'll tell you the answer is 8. 8 is the biggest number that goes into both of those. So you pull the 8 out and then rewrite what's left. 16 divided by 8 is 2, so we have 2y. And 24, when we divide the 8 out, there's 3 left. So yes, this is factored, but this is factored completely, they'll say. We popped that zip completely until we've got all the stuff out. Sorry if that's a little too gross. We can, I'll try to use something else. Let's say negative 4x minus 28. What can I factor out of both of those? Watch this. I can factor out a 4 out of both of them. What's left here? Where there's a negative left. And when I divide 4 by 4, I've got 1. We've got a negative 1x. And when I factor out the 4 out of this, I've got 7, so minus 7. So there it is. I factored it out. I can't take anything else out with this 1 and 7. That's it. Now you'll see them sometimes take the negative as well. Sometimes if there's a lot of negatives on it, they'll take the negative 4. The negative 4 divided by negative 4 is then a positive 1. And negative 28, when you divide this negative 24, becomes a positive 7. That negative, just like distribution, it changes the sign all the way across. And you can check your work. Negative 4 times 1x. Yep, got that right. And negative 4 times a positive 7. Yep, that's a negative 28. And what about when it looks a little more complicated? What if there's 3 terms in the expression? It still works, just find the biggest number that goes into all of them. For example, 2 goes into all of those numbers. And you might think, well, wait, does 3 go into all those numbers? Yes, 3. So 2 works. Let's see, 2 works. 3 works. 6 also works. So we can pull a 6 out and then write what's left. When I divide this by 6, I'm left with just 1x. And yes, you might see him not even write the 1. When I pull a 6 out of this negative 12, I've still got negative 2 left. And if you're ever not sure, you can just take that negative 18, divide it by the 6. When we divide the 6 off, we've got that negative 3 left, so it's minus 3. And we just work that through. For example, 12a minus 15b plus 6. What can I pull out of each of those? When you try to pull a 6 out, nope, that doesn't work. So the next biggest number we can try, we can just keep going down with the 6, 6, and then 3. Yep, 3 works on that. So that would become, when I divide by 3, I get 4. And I divide this by 3, so it's a minus 5. And divide 6 by 3, so it's plus 2. So on that one, we're dividing. And you can check, 3 times 4, yep. 3 times minus 5, yep. And 3 times a plus 2, yes. And one last example, if you need, negative 14m plus 28 minus 21m. What's the biggest number that will go into all of those? And if you, again, with the times tables, 7 goes into each of those. When I divide that by 7, I get negative 2m's. When I divide that by 7, I'm at 4, and divide that by 7, it's negative 3. Now, if you were thinking negative 7, that's all right. We can do that with negative 7 as well. So that leaves me with 2m minus 4. The signs are all different because I've taken the negative sign out, so it's plus 3m. Both of those can be considered a correct answer. All right, that's factoring. Expressions, just kind of like factoring numbers, but there's more terms. So just think like, I know it's gross, but you're popping is it. You want to get everything out. You want to get all of it out. So get all of the number out when you're multiplying and dividing and undoing those. You want to get out the biggest number you can. So thank you so much. Have a great day, and hope this has been enlightening. Talk to you later.